This project aims to design a prototype wheelchair that offers multiple control methods for enhanced accessibility and ease of use. The wheelchair can be controlled via a joystick and 4 push buttons for manual operation, while also incorporating MEMS sensors for wireless control through RF, radio frequency, technology. To ensure safety, the wheelchair is equipped with an IR sensor that detects obstacles in its path and triggers an alert using a buzzer. The movement of the wheelchair can be directed in multiple ways, including forward, reverse, left, right, and stop, providing the user with flexible and responsive navigation options. This design aims to improve the mobility and independence of individuals with physical disabilities, offering both manual and remote control functionalities for ease of use in various environments. The Advanced and Intelligent Wheelchair Control System for Leg Amputees using Joystick project utilizes a 16F72 microcontroller to provide enhanced mobility and safety for leg amputees. The system allows users to control the wheelchair with an intuitive joystick, offering precise navigation in various environments. It features an obstacle detection system that alerts users via a buzzer and automatically stops the wheelchair when obstacles are detected, ensuring safety. The design is energy efficient, cost-effective, and user-friendly, allowing for longer battery life and easy operation. Test users reported improved independence and confidence, and the system's scalability makes it adaptable to different wheelchair models,